So let's just look at briefly the description of the wave dynamics feeding on to these propagating features of MJO, and here the eastward intensifying ISV. So you have, let's say, a convective phase has happened, and there is a wet or the dry Kelvin wave going ahead and creating subsidence ahead of it, but because of the convection, let's say from the previous time, or just relatively speaking to the region of subsidence, let's say from the Rossby wave subsidence of the previous event, you have, let's say in the Western Indian Ocean, warm SST anomaly generated, and you have a cold SST anomaly ahead of it. So you have subsidence, divergence at the surface, high pressure, Rossby wave signature, and the Kelvin wave signature, and you have upper level convergence, low level divergence, low wind speeds, reduced latent heat loss, warming of SSTs, moisture loading of the lower atmosphere, and all that. Once convection is triggered, you have rising motion, and you set off the Rossby wave lows behind, and then the Kelvin wave, wet Kelvin wave or moist Kelvin wave, sorry, ahead of it that goes off towards the east. So we have the convergence into the convective region and upper level divergence, and then ahead of it you have convergence and the next phase of the warming ahead of it because of the same processes that we talked about here. So the building of the instability is already built into this wave dynamic. So the Kelvin wave, Rossby wave doublet that we talked about can serve both in the dry phase of the Kelvin wave, creating subsidence, and the moist Kelvin wave going off, propagating the convection to the east, are kind of a self-induction or self-regulation process. Okay, this is kind of visible when you actually filter the OLR and the even the SSTs and the winds and so on, rainfall, etc. Okay, for the eastern intensification, the situation is different. So you have subsidence, and you have a cold SST happening with the divergence at the surface. You don't have this structure. Remember, the Indian Ocean didn't have a signature for the eastward intensifying ISV. Then the subsidence gives you the warming and convective instability, and then convection happens, and you have similar upward circulation, of course, upper level divergence, the Rossby wave low signature, and convergence, but you don't have the wave dynamics creating the cooling ahead of it and preparing the system to reorganize the SSTs. So this is different, but as I said, it's not totally clear whether these are really different phenomenon or they are just diversity of MJO itself. This is the kind of cartoon schematics you will typically get. This is from NOAA, its blog site or its educational material on MJOs. So it's basically showing again stormy wet convective phase over the Indian Ocean side with low level convergence, upward motion, upper level divergence. Ahead of it you have the wave dynamics doing the downward motion, divergence, sunny dry conditions, reduced latent heat loss, and warming of SST, which gives you the propagation. Okay, but the propagation across here is what the book creates or classifies into eastward decaying and eastward intensifying ISVs. Other frameworks say that there are MJOs that do not cross and get stuck over here, so you can call that eastward decaying. There are some that cross and then they re-intensify on this side. The weakening of this side is blamed variously on the topography, which is obstructing the eastward propagation. There are 20,000 islands here which create this ocean land contrast, and land is low heat capacity, so it can warm up and give you strong diurnal cycle, which is argued to take away the energy from MJO. And there are other processes associated with moisture loading to the south, which end up steering along with air-sea interactions in the Indonesian seas, steering the MJO to the south and propagating across here between Indonesia and Australia and coming into the South Pacific convergence zone. So the interpretations are slightly different, but the processes are kind of interpreted by looking at the tropics as eastward decaying or eastward intensifying versus the canonical MJO, which is crossing over. Okay, that's kind of the wave dynamics feedback. But again, the many questions remain as to exactly what creates the conditions for eastward decaying, eastward intensifying, or just crossing across the maritime continent as if there is no barrier. So all hypotheses are out there. Data are never enough, and the models are not always good enough to answer all the questions. But this is a very active community, MJO, lots of modeling experiments, observations. There's a program called Years of Maritime Convection, YMC, which is collecting massive amounts of data over the Indonesian seas, which is which was called the Boiler Box by Ramage, and it's called the Mix Master by Arnold Gordon for the ocean part. So there's lots of processes happening in the ocean and in the atmosphere, and something happens at interannual timescales during El Nino, as we saw with the Indonesian, so Indo-Pacific tripole. There is a strong relation between Indonesian rainfall and Indian Ocean, which can explain parts of the Indian Ocean dipole, and so on and so forth. So the timescales are rather rich in spectrum, but the processes, a lot of them remain not fully understood yet. So we will look at some of the low frequency background state to confirm, to restate these points, and then look at a list of MJO theories to again re-emphasize that there are many theories, which means we don't have a full idea of exactly what happens, and that's the way life goes, right? Science keeps building based on data, so we keep collecting more data to build theories and test theories.